Hello, everyone, and welcome to today's SANS webcast, The Power of Fusing Network Alerts and Evidence with Open Source Suricata and Zeek Bro, sponsored by Corelight. My name is Jessica Gallus of SANS, and today's featured speakers are Alex Kirk, John Gamble, and Matt Bromley. If during the webcast you have any questions for our presenters, please enter them into the Q&A window located on the control panel at any time. Please note that a copy of the slides and recording of this webcast will be made available for viewing later today and can be found on the SANS webcast archives. And with that, I'd like to turn the webcast over to John.
Thanks, Jessica. A quick preview of our agenda. You may have heard of one or both of these tools prior to today's webcast. Perhaps you've heard of Suricata but not Zeek, or Zeek but not Suricata. We'll be covering both tools so you get a good baseline understanding of each. And then we'll be diving into kind of the meat of today's presentation, which is really how these tools together are really can drive great outcomes, and they're better together. And so we'll be walking you through some technical joint use cases of these two tools. We'll be closing with a brief word from today's sponsor, Corelight. I'll be kind of explaining our products and how we can help you deploy Zeek and Suricata in your own environment. And we'll close with a Q&A. As Jessica mentioned, feel free to ask questions during the broadcast, at any point. I'll see it there in the Q&A tab that I'll be monitoring, and we will save some time at the end to answer your questions. So with that, I'm going to turn it over to Alex Kirk, who's going to give us a brief background on Suricata. Oh, sorry, I misspoke. Let's just introduce today's speakers. Alex, perhaps you could give us some detail about your background.
Certainly, John. Thank you. So I spent 10 years with SourceFire's research team, writing snort signatures, picking apart malware, doing all that kind of fun stuff. And I'm excited to be back in a small company environment doing work with a very similar product in Suricata.
Excellent. Matt? You are muted, Matt. There we go.
Hey, everyone. Yeah, sorry. I had a little bit of noise I wanted to get past in the background there. Matt Bromley, everyone, with the SANS Institute. I've been on multiple webcasts with the Corelight folks here. Super excited to be back on with John and be here joined with Alex as well to walk you guys through some really, really awesome analysis features. And I think for like the next level of network security monitoring, which in my opinion is where we need to be at. So excited to be here. Thanks, John.
Thanks, Matt. And as I mentioned, I'm John Gamble. I'm Director of Product Marketing here at Corelight. And I've been with the company a couple years and represented a number of security products in the space. And I think Corelight's got a lot of really awesome, innovative stuff that we're going to talk about later in this presentation that I'm excited to tell you about. So with that, I will turn it over to Alex to talk about Suricata.
All right. Thanks, John. So again, for folks that might not be familiar, it looks like we're having just a bit of screen advance fun because we have skipped a slide there, so apologies. Suricata is a pretty widely deployed open source IDS, IPS tool. It sprang from roots very closely associated with snorts about 10 years ago. It is, again, in that open source GPL specific kind of heritage similar to snort. But freely available to the community and definitely has a large following of folks out in the open source world as a result of that openness. The kind of primary use case around Suricata is to have alerts generated on your network traffic based upon a set of signatures that you can load from any of a number of commercial providers, open source communities, intelligence feeds, etc. And all of that data is going to be output as JSON primarily for enterprise environments. It's possible to do ASCII output as well for smaller shops. But typically, this data is going to be passed off into the SIM of a SOC's choice to be viewed as part of a broader set of network data as opposed to necessarily being confined to an individual console. In particular, because there's so much of that surrounding data that is often necessary to make sense of the alerts coming out of Suricata and decide about their actionability. So it's definitely an important piece of the security stack, but not a standalone tool necessarily on its own if done properly in the wild. Now, in terms of actually deploying it from an open source perspective, you're going to have to go out and acquire some kind of hardware to put it on. White box hardware will absolutely do the job for sub-gigabit kind of throughputs, although things get more complicated as you get into very large enterprise networks, that 10 gig link kind of segment and above. There are pre-built packages available through apt or yum on your Linux flavor of choice, but since those packages can sometimes lag what is current and don't give you the option to compile in things like signature performance profiling, for example, a lot of folks will actually build this tool from source from scratch to make sure they've got it customized to their liking. From there, you have to actually go and get some kind of a signature set. There's not a default set that comes directly with the Suricata distribution, although there are several sets that are known out in the wild that are often easily associated. You're going to have to take that step yourself of setting that up and making it happen. You're going to have to find some kind of a way to get packets into the environment. And while it is possible to run Suricata in inline mode, a lot of folks will hang it off of a packet broker or a span or a tap so that it's out of band and doesn't have the possibility of causing network disruption with any kind of latency or potential false positive out of the signatures. From there, you're going to have to figure out how to do the mechanics of actually exporting into a SIM, which can sometimes be a bit of a complicated process with things like Kafka buses or Elasticsearch ingest or you name it. And then once you actually have the data in that SIM, then there's the ongoing process of tuning those signatures, seeing which ones are reliable in your environment and which ones may make less sense for the setup that you've got, and keeping those tuned to a point where you're not only performing well, but you're giving reasonable, actionable data off to your analysts with that alert stream coming through down. So to talk a little bit about a sample alert that you would get in Suricata, there's a decent amount of metadata that is statically written in at signature time that tells you, the signature name. This one is a generic suspicious post to a dotted quad host, which is essentially the HTTP host being an IP address instead of a domain name with a fake browser user agent string in this particular case. But you're also going to see things like when it was originally created, when it was last updated, so that you can see if it's being actively developed. And then you'll get dynamic information as well based upon things like the source and the destination IP address, the ports that it was running over, the timestamp, etc. And one of the other things that's provided as an option in more modern versions of Suricata is some additional metadata that goes along with the alert. The Suricata project has said for a while that it's common to deploy side by side with metadata tools, and it's necessary to have some of these basic pieces of metadata in there in order to resolve alerts more quickly. And so independent of anything to do with Zeek, they've decided to include a subset of the metadata that is available within a more dedicated tool like Zeek to assist analysts in trying to come to a conclusion quickly. So that is kind of the high-level overview of Suricata there. I'm going to go ahead and pass this over to Matt to talk about Zeek.
Awesome. Thanks, Alex. Appreciate it. And yes, Zeek, everyone, my favorite network security monitoring tool. John, I was thinking when we were putting this webcast together, I was thinking that we're going to get to a point where we're going to have to start to take away the formerly bro part, because everyone's going to forget that it was ever called bro. And it's going to be a very sad day when we put together a slide deck and say, I think we need to put this anymore. But for those of you who have been around and have definitely had experience with this tool before, you obviously know this as bro before it was renamed Zeek in 2018. A very tried and true, widely deployed network security monitoring tool. It is fully open source. And it is quite frankly one of my favorite tools to approach network traffic with, because it gives you that multiple layer protocol specific based analysis. Zeek's also got its own built-in scripting engine. It gives us the capabilities to work with content as we observe it. So it's not just generating logs, not just dumping output into a text file that we need to go analyze. You know, we've definitely had a good series of webcasts where we've used Zeek or talked about using Zeek and formerly Bro to extract files, to create automatic lookups, do intel matching, do all sorts of kind of scripted operations on files that you may observe in a PCAP or traffic. And, you know, I think it really gives you a really nice level up when you talk about that custom scripting capability. I've seen we've had a couple of questions come through. I'm not going to answer them yet, but I have noticed that there's a trend that talks about Zeek and Suricata working together. And I just want to let everyone know it's exactly what we're going to be talking about on this call today, is bringing these things together into one and making them work together. So yes, you're going to see these things interoperate with each other. And for me, a lot of that is very possible and capable because of the scripting engine, because of the output control, because of what we can do with the tool. I do want to make another note here that I can remember a day, and I'm sure a lot of you do from a network, from a Zeek or Bro perspective. I can remember a day when it was kind of pretty straightforward text files or log files that were dumped out on disk, followed up with some pretty cool command line kung fu. And I think Zeek has really taken steps forward now to provide different output options, have much more control over output, and also integrate into SIM and give you a really, really nice vantage point into your network. And that's actually one of the most common uses that I'm seeing of Zeek these days, is to generate data at a really, really granular protocol level, and then have that data dumped immediately into a SIM for further correlation and analysis. And it's really cool to see the way that that things have progressed from a Zeek and tooling perspective here. Again, it is an open source tool, fully open source. You're able to go and utilize it right now if you'd like to. The really nice thing about the open source community, especially the community behind Zeek, is that it's very, very compatible with multiple systems. It can be deployed in a multitude of different operating systems and environments. Really straightforward process here. Grab hardware, get Zeek on there, feed it packets in some way, shape, or form, and then push that data where you need it to go, and then start to perform analysis. Now, full disclosure, when we walk through a few case studies here as part of this particular webcast, we're going to be doing analysis on data that comes after Zeek. So we won't be walking through the integration or implementation process necessarily, but I want you all to know that it is a pretty straightforward binary setup, binary download, and then packets just simply feed through Zeek as it's running on a system. What you do with the data afterwards is going to be the most important takeaway of using this tool. And that's what we're going to focus on in part of this webcast here, is what we do with that data afterwards and how we combine and marry it with other sources. And I think for me, that really steps into kind of step number 5, which is tuning the data for your particular environment. And there's an important note I want to throw out here. Between Alex and myself, we're going to walk through a handful of case studies, and we're going to talk about ways that Zeek and Suricata working together can be a really, really powerful network monitoring tool. But I want to make one quick reminder for everyone on this webcast today, and those of you watching it in the future. If you are currently not engaged in any sort of network security monitoring, maybe this is the first time you're considering network monitoring or packet analysis or things along that line. Let me just make a note that this is going to be something that you're going to need to work at. You're going to need to fine tune. You're going to need to hone it towards your environment as you deploy the tool and as you use it more and more. And that goes the same with a lot of different security products that are out there. The reason I'm throwing this here is because now Suricata is in the fold. And I've seen, and Alex kind of talked about this just a moment ago, and we will discuss Suricata rules a little bit later on, but this is not a setup or an environment where you just turn on everything and hope your analyst can wade through the fire hose that's going to be shouting out. We're not going to be dealing with that. So in any event, I just want to throw that out there, as always, that it's going to need to be tuned. It's going to need to be honed towards your environment. But once you get to that point, you're going to find it's a very, very useful tool. Once you've got it implemented, let's talk about analysis in Zeek, everyone. Now, pause. I'm going to talk to you about Analysis in Zeek right now. Pretty soon, I'm going to walk you through doing Analysis in Zeek and Suricata together. So let's set the baseline. Zeek by itself has the ability to do very, very granular protocol inspection on your traffic or on your recorded PCAP files. I want to make a quick note. With regards to some other protocol analyzers that are out there or some other NSM tools that are out there, a lot of them may ship with restrictions or they may ship with pre-built rules in place. And here, I'll throw a couple questions out there for everyone. What normally transpires over port 80, over port 443, port 22? If you can answer those pretty quickly, unfortunately, some tools are written that way. One of my favorite feature sets of Zeek is that it never, ever adhered to what I expected to see, because attackers don't follow what I expect to see. Attackers will find ways to go around what I expect and go around what I'm monitoring. And this was actually one of my first introductions to Zeek, or Bro, went back in the day a long time ago, was protocol recognition regardless of the expectations. And you can find some really, really interesting results by analyzing your traffic from a protocol perspective as opposed to a port perspective, as opposed to an expectation, if you will. As such, Zeek is going to break out that traffic into protocol-specific logs. So we've got a few examples here. Full disclosure, and John, I don't know if before this webcast is over, we can get a link to some of the cheat sheets you guys have put together into the chat. If not, we can certainly make them available on the webcast page. But what you're seeing here, everyone, is a little cheat sheet that the Corelight team put together. Don't worry, it's fuzzy. You're not supposed to read the words. I don't want you to read all the tables in here. What I want you to do is just follow along the analysis chain. And you'll notice that we get logs. In this case here, we're looking at con, which is your connection log. That's going to include your really, really basic high-level information about connections that Zeek has observed. And then we get into our protocols, DNS, HTTP, and you'll see SMTP as well. Files.log is yet another example of Zeek's extensibility. There is obviously no files protocol, but it's an extension where Zeek is also aware that, hey, there's files that cross the wire, whether it's HTTP, whether it's SMB traffic, whether it's FTP, whatever the protocol may be, there's plenty of situations where files traverse the wire. So Zeek goes ahead and it profiles those for you. Remember a few minutes ago, I was talking about that scripting engine, the ability to go above and beyond just simply waiting for text files and waiting for alerts. Files.log is a good example of that. There's one key data point inside of here that I need you all to be aware of right now. And it's the second one down in the list at the bottom. It's the UID. Every single connection that gets observed by Zeek gets given a unique ID for that particular connection. And the nice thing is, and now you can look at the tables, see those purple boxes that are kind of tracing across the wire, everyone? They're in the top for each and every log that's in there. Those are your UIDs. Those UIDs are going to follow that connection around through the logs, and they're going to serve as your first integral pivot point. And in fact, that's actually one of the primary focuses of some previous Zeek webcasts of ours, has been how to efficiently utilize that connection UID. We get some other metadata dropped in there. For example, the files log. I can configure Zeek if I want to MD5. I can configure Zeek to SHA-1. I can configure Zeek to pull all sorts of details down to give me a separate log. Heck, we can even, if we want, configure Zeek to extract the files that it observes. Don't just collect metadata, go ahead and extract them. And that's where the final data point that I've got in here, the FUID, comes into play. Notice we had a UID before, that was our connection UID. There's also the FUID, which is the file unique identifier. And very similar to the previous concept, I get a unique ID for every single connection. I get a unique ID for every single file as well. And what I've got here, everyone, is a very robust way to observe the traffic in my network or observe a historical PCAP, correlate events, regardless of protocol, correlate events across themselves, and correlate files that may have traversed across the wire as well. Usually, this process is pretty lengthy. Usually, there's a pretty lengthy lookup process that's baked into performing analysis. One of my favorite features of Zeek has always been the fact that this is done for us on the surface. So we've got now an introduction to Suricata, and we've got an introduction to Zeek. And I told you to remember a couple of things from Zeek. Remember that unique identifier, and remember the fact that Zeek is protocol aware. So I'm going to walk through two particular use cases, and then I think Alex has got one for us as well about bringing these particular tools together. But I think before we do this, John, I don't know if you want to open it up for discussion or not here, but I'll just start off by saying everything I've talked to you all about before in the past few minutes has been protocol recognition. It's been, oh, go look at your HTTP logs, go look at your DNS logs, go look at your con logs, go look at your files. But for those of you who work in a SOC or have done analysis or work in security reporting, what value is all of that data to you if you have no clue the difference between good or bad? John, I don't know if you, it may be a quick discussion point for everyone here. For me, I need context as well as evidence, or signal and evidence as it's called out here, in order to make more sense of what it is I'm looking at. Are we in agreement?
Definitely. And I think also, there's a lot of tools out there that are signal-driven, signal production tools that will include some context. They'll include some evidence as part of the alert that they generate. But usually the scope of that evidence and that context is pretty limited, pretty myopic, and kind of focused on the alert itself. And what you really want is you want an independent tool that's objectively logging evidence across the system, because inevitably when you start tugging on that thread of a given alert, whether it's coming out of Suricata or a different tool, you're going to want to pivot outside of that frame of reference of the alert. You're going to want to say, okay, but what happened before this alert fired? Okay, but who else was talking to this IP address in my environment? Those kind of broad and also specific questions that you want to objectively answer about your environment, you're not typically going to get that out of a signal-focused tool. And so it's Zeek that's really focused on generating evidence, objective reality of kind of wire traffic, that putting those two things together is where magic happens. And Alex and I were talking the other day, and we picked this slide. We were talking about, peanut butter and jelly, Bert and Ernie. We settled here on Bert and Ernie, and Suricata in this case being Ernie, and Zeek being Bert, just because we thought personality-wise those tools kind of match. Alex, I don't know if you have any other commentary there.
Yeah, Zeek has always been a little bit more of a serious, studious academic project, and Suricata was more of a community upstart, and in your face, publicly self-promoting. Then Zeek was a little bit more quiet and professorial. But bringing those two communities together, I think, is going to do a lot of good, just for cross-pollinating thought between them, and looking for ways that they can be used jointly to help the entire Defender community.
You guys are tugging at my heartstrings with some of these words here. Entire Defender community. Those of you watch this webcast, you hear that? That's you. Entire Defender community. We're here to try and make your lives easier and your jobs easier. John picked up on a really important concept too, that I want to make sure everyone here has a very, very good understanding of. And it's the concept, I typically, those of you that I've had in class before, or have maybe heard me discuss this topic before, it's something there's probably an official name for it. I've just always called it temporal proximity, or just kind of event proximity, if you will. And to John's point, there's a very important analysis concept, which is the asking the question of what else happened around my particular event. What else happened at this time during that 5-minute window? In my experience, I have never, ever, ever seen an environment where the ones and zeros line up perfectly and a piece of malware just poof, appears on a system. Never happens. I've never seen it happen before, at least. If everyone's ever seen that, let me know. I know some of you have claimed that it happened, but it doesn't. Malware's got to show up in a certain way. Attackers get into a network a certain way, and the network ends up being the common denominator for all of that. So when you come across a particular incident, you come across an event, you come across an alert, you're investigating some traffic, whatever the task at hand may be, keep the concept of context and proximity in mind. And that's really where signal becomes strong, when you have the evidence, everyone, when you're asking the questions of what else was going on around the same time and what else was happening at the same time frame, because we know that these things don't just materialize into any sort of malware or attacker activity. Now, not to say everything that you may observe is bad, obviously, but let's walk through an example really quick here of what analysis used to look like. And I say used to because on this webcast, we are defining a new way to do analysis here. We are defining a way to bring Suricata and Zeek together to give you a more advanced and enhanced analysis process. So how do we do this? What does this overall deployment look like? And you may notice, everyone, for Suricata and for Zeek, we had a slide that focused on deployment. We're going to do the same thing here. But in all honesty, this is not a super complex process. I'll be very frank with everyone. Just to test out and just to give you this one-line sentence right here, I went ahead and set up myself a little Suricata and Zeek test VM this morning. And I did so under pressure just to make sure I could get it done in time and say this. It took me about 15 minutes total to get myself a little VM set up that had Suricata and Zeek working together, interoperating, and reporting on the same data that I was able to use to correlate. And in fact, you're going to see some of those screens, well, not these screenshots, those are a little earlier in time, but you're going to see some evidence of this correlation very, very shortly. So I want to just make a point that on the surface, this is an easy install to set up. Now, if I'm going to go into a production environment, and this is something that I know John's going to talk about a little bit later when he talks about Corelight's feature set, because they've certainly walked through these patterns a lot, more lengthy than we all have. But compile these different products or compile these different tools, get them installed, estimate the workload, assign cores, and then let it rip. Let that traffic flow in, get that traffic to Suricata, get that traffic to Zeek, get the logs out, and then get that evidence to an analysis platform. You're going to notice two different sets of analysis in the case studies we're about to walk through. I did all of my analysis on the command line. I didn't do that to show off. I did that because in some cases we are doing ad hoc network analysis or we're doing ad hoc log analysis. Some of you may notice when Alex walks through his case studies, he's in a SIM. That is intentional. That is to show you all that this analysis can be done in multiple different ways because the data is the same and my pivot points don't change. And that's what I want you to take away from this is the pivoting from the alert into the evidence and how we work through that. So, all right, here's use case number one, everyone. And this is going to be the way that things used to be done back in the day. So I would take a PCAP or take a particular piece of traffic and I would pump it into Zeek and I'd get these logs out. And you may notice left-hand side of your screen, there's a list of a bunch of different log types. We're not going to walk through each and every single one, but the nice thing about these log types is I used to be able to take some traffic, take a PCAP, and I used to be able to run it through Zeek. And I used to be able to do a quick scan. All right, what types of protocols do I have inside of here? HTTP, Kerberos, NTLM, SMB activity, SSL, X509 certs. And the cool thing is, then I could start to parse through my logs piece by piece, and I could dump all this data out. There's my SMB mapping shares. Here's my files that have been transferred across the wire. There's some of my domain controller or my Microsoft Active Directory traffic, my DCE RPC stuff that's been going on. All right, I'm getting really good insight into my data. Oh, look, I've even got some DNS hits in here that I could work through. Do you all see where I started with this example? I started by saying, oh, look, lots of data. Let me just go ahead and skip through some files and see what I can find. Oh, and luckily I came across a bad domain, something with a .onion at the end of it. Okay, great. But is that good or is it bad? I don't know. Let me take that exact same traffic and let me go ahead and run it through Suricata as well, off to the side. Remember, I'm doing this analysis, everyone. This is the way things used to be. I'm not integrated at this point. I'm doing things ad hoc. I'm doing things one by one because I'm not following a good analysis workflow. But I got some traffic, got a bunch of logs. All right, this looks good. Let me go ahead and start to run it through Suricata. Oh, look what came up. Look at that. I've got a whole bunch of different alerts flagged in this particular PCAP here. Suricata did not like this PCAP at all. I've got potential JA3 hashes. For those of you curious about JA3 hashes and what that means, go check out a webcast on dealing with encrypted network traffic. So, by the way, some of you have asked questions already in the Q&A about encrypted traffic. JA3 is the next Google thing, is the next search term I want you to go Google. We've also see SMB file transfers. I see, interesting, some SMB create and request. I've also got some C2 activity, DNS stuff taking place, exploit, all kinds of things happening here. Cool. Tell you what, everyone, let's pick on that SMB vulnerability. Oops, looks like I had a log entry, animation fall out of line here because I've got a log entry previewed for you. So here's a snapshot of the Suricata logs showing me that particular CVE. All right, I've got my source and destination IP. I got my port information. Let me go ahead and line this up with my DCE RPC logs. Look at this, everyone. We are humming along doing analysis at the speed of how fast I can type on the command line, which most of the time is pretty slow. This is a very, very slow analysis technique, going through and manually correlating IP addresses to Zeek logs to try and get insight. Now, before any of you say this, you might want to throw out here, but Matt, if you were to look at the Suricata logs, you'd notice that it has some of the same content traffic in there. It's got some, you're right, not all. I want all the evidence. I want to have these things working together. So in any event, we could continue working through this process. Tell you what, let's take one of the other alerts that fired. I'm concerned about this particular event because I saw in my Suricata logs that there was some SMB executable file transfer. That's a very specific signature, everyone. That is not SMB file transfer. That's SMB executable file transfer. That means someone found that PE header and identified that an executable was being transferred across the wire. Let me go ahead and take that IP information. Let me bump that, go back to files.log, pull all of those things together, and look at these funky named executables that traverse across the wire here. Now, I'm going to do a little bit of Zeek pivoting here as well. Remember when I talked to you about the Zeek setup, I told you about that unique connection ID. So I'm going to take the connector ID from my files.log, take a look at the left-hand arrow, my files.log, and then run that through some of my other log sets as well. And the nice thing here is I am now able to correlate traffic that I saw, traffic that was identified by Suricata as potentially malicious. And I'm able to correlate that with files.log, which showed me the file transfer. And then I'm able to take that connection ID and use it to pivot throughout my other Zeek logs and correlate and bring all these events together. Unfortunately, then I know there's text on the screen. You don't know what it means yet. Don't worry. There's an animation out of sync, but it's okay. At this point in time, everyone, I've wasted far too much time in analysis. What I did is I generated these two different data sets independently, and then I spent some time correlating the two of them together. Now, yes, there are ways I could have made this more efficient. I could have pumped everything into a SIM and done my lookup and analysis that way. But did you all notice? I am taking data points from Suricata, and I'm trying to use those data points to pivot into Zeek, IP addresses, ports. This is really easy on a 15 meg PCAP. It's really hard on live traffic. It's really hard on hundreds of megs or gigabytes of traffic coming through the wire. So how do we make this more efficient? We bring these two things together. Last time, I started at the Zeek logs. On this use case, I'm not going to start at the Zeek logs. I'm going to start at Suricata. And I also did a little something different in the background, which you're about to see in just a second here. I started at Suricata. And do we have anything concerning inside of here? Oh yeah, you better believe we do. I've got some post requests going out to a C2. I've got some more JA3 stuff happening in here. And it looks like I've got some likely evil executable downloads coming through. Before you ask, yes, I downloaded and turned on all the rules. They'll never do that in production, but I did it just for the purpose of this example right here. So with that said, I don't want to start at an alert and pivot from there, everyone. So I'm going to change my output on you a little bit. Notice how this changed? Here's what I did. In my little test instance, I configured Zeek to display the community ID that Alex talked about a little bit earlier. I also configured Suricata to display that community ID that we talked about a little bit earlier. Both tools configured to output the exact same data that links these two events together. And then I started playing with my output a little bit. And I said, instead of tracking down based on a particular alert and an IP address, why don't I start tracking down based on the unique community ID? What you've got here, everyone, is the alert followed by its unique community ID associated with it. Watch how my analysis changes in this aspect. This was my old C2 discovered activity. Here is now my unique ID. Now, granted, this is not all of them. I'm going to take that top one. And let's do the same search again. I'm going to take that unique community ID from that first alert, and I'm going to correlate it to my con log. And guess what my con log is going to give me? It's going to give me that unique connection ID that corresponds to all of my Zeek logs and brings everything together. So I'm just going to go ahead and kick off a really easy command line grep and bring all of these things into the same place. So I had an alert that fired. I took that alert and I was able to, via one pivot point, instead of multiple files, instead of greps and awks and seds and doing all this stuff on the command line that I used to have to do, what I can do now is simply look for that one community ID, find the alert I'm interested in, and throw it against the rest of my Zeek evidence, and boom, all of the log entries just float up to the top. And now I can see that that particular post request was obviously an HTTP. There were some files associated with it as well. I can see the file unique ID. I get the IP address. Everything is called out in one location. I can repeat this same exact analysis for some of my other alerts that got detected. And we can go through and, oops, sorry, my apologies, went forward one. I can continue to repeat this again and again and again for various types of use cases. So I want to summarize my use cases before handing it over to Alex really quick, because I want you to walk into his use case with one thought in mind. First off, well, not sorry, not one, two thoughts in mind. First off, analysis is now significantly easier because I have interoperable pivot points. That's the first big takeaway. The second big takeaway that I want you to keep in mind is I now have one way to bring all the context into one analysis screen. I have one way to bring everything into one place, whether it's a SIM, whether it's on a command line, no matter what type of data I'm looking through, or what the incident is. I picked on SMB and C2. What happens if I've got an email threat? What happens if I've got another protocol-related threat and I need to pivot off those alerts? My analysis is really easy if I focus on SMB and HTTP. What happens if we do some more complex protocols? And that right there, everyone, is the benefit of having signal and evidence together, is I can let Zeek do what it was designed to do, handle protocol parsing. I can let Suricata do what it was designed to do, the alerting, the signal intelligence. And then I can bring those two things together and do analysis significantly faster. Now, with that said, I want you to walk into Alex's use case now, because he's going to take you into that SIM setup, and he's going to show you can do a more advanced, maybe more current attack at scale utilizing correlated data. Alex, over.
Excellent. Thank you, Matt. So let me go ahead and make sure that I actually have proper control here. Thank you. So what we're going to do is sort of a similar thing to what Matt was just talking about, starting off of a Suricata signature that is specifically for PowerShell activity over SMB that they have tagged as likely lateral movement. And using the signature ID that is available in the alert, we can pull up the actual signature itself and be able to see that it's looking for that SMB header on the appropriate port, and then just generically the Unicode version of the string PowerShell.exe, which is typically enough to be something that is worth investigating. It may have the occasional false positive either from administrators using PowerShell in strange ways across the network to accomplish their end goals, or perhaps from having that string appear innocuously in chunks of other data. But it's definitely one of those things that if you're getting this alert in an environment, you want to look closely into it and see what the heck is going on. And so using this community ID that Matt has talked about, we can very quickly, again, pivot in, I can hit advance here, to the connection log where that community ID is going to be generated on the Zeek side of things. And from there, go ahead and grab that Zeek UID and use that for further pivoting into the layer 7 logs. And the beauty of modern SMB command execution across the network is that it actually does so across a consolidated SMB TCP session. And so pivoting on that one UID, which is set for a single TCP stream, you're going to be able to get SMB file information, Suricata events that are also generated on the same stream, DCERPC, all of these different logs from that single pivot point. And they're going to give you a lot of the context that you need to make an intelligent decision about whether or not you want to track something like this further down. For example, with the NCLM log here, we'll see the host name of the system that was sending the traffic and what domain it's connected to. what user is involved, really making it a lot easier than just having the IP addresses giving you human readable context on an immediate basis, again, with no kind of correlation to any sort of third-party asset tracking or other systems necessary, just by reading the traffic that is in what's actually going across the wire. And, even if you were to have, for example, a more enterprise network that was running Kerberos instead of NTLM, while some of the user information is obviously obscured by the Kerberos encryption, you're still going to be able to get information about the client system that is not obscured during that transaction and give you more context as a human to be able to go and make a priority decision, if nothing else, based upon what's going on with the traffic here. But taking all of that context as a setup, the real kicker is being able to come into the DCE RPC logs and see what exact operations went on with this traffic. And if we look closely in here, we see that there's a connection to the net services name pipe, which is a standard kind of Microsoft remote execution pipe that is available out in the wild. Speaking to the service control endpoint on the machine, which is, again, a core Windows function. And the operation that is taking place here to start anyway is the opening of Services Manager to attempt to do something with a system service on the remote machine. And, while this particular action by itself is not necessarily a smoking gun, what we see in these logs is actually that we've also got a create service going on, followed by a start service, which is okay, fine so far, but then, oh, look, a delete service, followed by a close service handle, all of which are occurring within the span of literally less than 1 second in time. So obviously, automated execution of this service instantiation, and again, very suspicious versus normal administrative activity. It is super rare to create a service from scratch and then delete it the moment it's been started. That's obviously an attacker attempting to cover their tracks, or at the very least, a sysadmin who needs a good talking to about what are legitimate administrative practices within the network. And again, this is all something that I can do with just 2 pivot points coming off of that Suricata alert, very simple queries within the SIM of your choice. And, this ability to kind of quickly investigate things becomes very relevant when you talk about the number of these alerts that can be generated very quickly by a Suricata implementation. Anybody who's been around the industry for a long time might be familiar with the old term, the scrolling window of doom. It's about the volume of alerts being generated by IDSs being so high that analysts have a difficult time keeping up. And that was true all the way back in 2004 when Gartner declared IDS to be a dead technology, up until the 2019 SAN SOC survey was pointing out that typically SOCs are seeing at least 10,000 alerts per day with an average analyst staff size of no greater than 10, and looking at a point where they've got to be handling multiple alerts per minute to keep up with the flow of things, as opposed to the 10 plus minutes it typically takes to dig through all the data and kind of manually extract things and figure out what's going on to resolve an incident. And to give you an idea of kind of why this is the way it is and the value of, again, bringing these 2 tools together, SMB as a protocol is a terribly noisy thing. So this screenshot of all these create request files that you see out of Wireshark here is literally for a single file being transferred from my Mac to a pre-mounted SMB share on my NAS here inside my home lab. I blame the Microsoft folks, at least the ones who were there 15 years ago or so when this protocol was being written, as well as Apple for making some of that noise here. You'll notice that I've got a COM Apple quarantine file being created automatically under the hood by Mac OS. But it's going to boil down to, because you have so many of these requests actually taking place over the network per the protocol specification just to do that one file create, you end up, this PCAT generated 9 signatures or alerts, I should say, for the create index request for a DLL file and 1 for an SMB executable file transfer. And so, you know, if you don't, as an analyst, have familiarity with those alerts already, you might think that you have, you know, a really bad case of prohibited data transfer going on. But if you come into the Zeek logs, specifically for the SMB files log, you're going to end up getting a single file write action logged event here that quickly pulls out the name of the file and gives you the protocol analysis intelligence to be able to say, well, this was really just one file transfer that will have logged the file with that FUID for you to be able to pivot through as appropriate, instead of having to wade through a pile of 10 alerts for a single file transfer like that. And what this really does in terms of analysis is enables you to do things like, all right, I'll go ahead and grab the community ID out of that Suricata alert, pivot over to the conlog to get the UID, and then be able to, in a single query, say something like, look in the SMB files log for an action of SMB file write on this UID with the name of .dll, and be able to say, oh, well, actually, it looks like this was just a developer dropping a copy of a software library on an SMB share. This is not something that I actually need to worry about lateral movement going on with, because I can very easily, as a human, see that this doesn't look like suspicious activity so much as a software project being copied to a network share. You know, this would be opposed to, in the cases that, you know, PS exec example, somebody trying to drop a malicious DLL on a share to be executed, you would get one of those things. And so it's going to look very different than that pile of alerts that came through on something that was actually fairly benign on the far side. I'll go ahead and pass it back to John here for a moment.
Great. Thank you, Alex. So yeah, where does Corelight fit into this picture? So Corelight makes a suite of network security monitoring sensors based around Zeek. So it is a commercialization of Zeek, and it provides all of Zeek's capabilities that were described in the first part of this presentation. We were founded actually by Zeek's inventor, Dr. Vern Paxson, and some of the key open source contributors to the project. And so kind of our initial vision as a company was to get Zeek at commercial scale in all of the environments with all of the enterprise level features and integrations that our customers wanted. And that's what we delivered. And so we've got sensors that can help you monitor your cloud environments in AWS and Azure. You can run them in virtual environments on VMware or Hyper-V. We also have a range of physical appliances to help you monitor local networks, you know, in terms of varying throughput sizes. And notably, with our recent software release, which came out last week, we have now supported Suricata on our top line appliance, the AP3000, which is our 25 gigabit per second nominal throughput sensor. And we've done more than just simply put Suricata on a box or bolted Suricata on top of our custom Zeek instrumentation. We've done a couple things that actually kind of make this a 1 + 1 = 3 addition in our AP3000. One, we've made the process more efficient by actually sharing the CPUs on that box across both tools. As I think Matt Bromley mentioned during the open source slide for joint deployment, part of that process, if you're an open source Zeek and open source Suricata world and you're trying to set up your own sensor running both of those tools, part of that setup process is estimating the workloads of each of the respective tools, Zeek and Suricata, and then assigning workers and cores to those respective tools. So you're basically making an upfront estimation about, okay, this is my traffic profile, this is my throughput, this is what I think I'm gonna need for Suricata, this is what I think I'm gonna need for Zeek, and then you're kind of locking yourself into those assumptions. And if you get them wrong, and it's tricky to, I don't think anybody gets it perfectly right, and of course traffic mixes evolve and grow over time, you're going to run into bottlenecks. You're going to find traffic throughputs that are exceeding the capacity you've assigned for those tools, and then you're going to start running into problems downstream where you don't have the alerts being generated or the data, the evidence you need to investigate those alerts. So what Corelight's done in our AP3000 sensor is a pretty unique architecture. We're not aware of anyone else doing this out there in the market today. And we're dynamically sharing those workloads across shared CPUs, which gives you bottleneck-free performance. You won't run into those bottlenecks you would in the open source world with our AP3000 because we're dynamically assigning those workloads across a shared CPU infrastructure. So it's going to deliver a much more reliable performance at enterprise scale with this commercial sensor. The other thing we've done that's notable that goes beyond the open source design pattern of putting Zeek and Suricata on a single sensor is we've integrated the data set. So we're actually running the Suricata alerts that are generated on our AP3000 sensor back into the Zeek event processing engine. And so now those Zeek alerts, Matt showed you on that very first use case, kind of the old way of doing things where it was completely segregated data sets and you were, manually querying to get between the two, right? As one end of the spectrum of kind of, that's a workflow that's not particularly efficient, versus at the far end of the spectrum, what Corelight has done is extended even beyond that community ID that's been mentioned in some of those use cases to make the data set pivot even easier. So what that means is that when you get a Suricata alert with Corelight's AP3000 sensor and you stream that alert into your SIM, it's natively embedded into the Zeek framework, which means the UID, that pivot you had to make in the open source world from, all right, community ID, pivot to UID, pivot to the Zeek logs I want, that middle step is gone. You don't have to do that anymore because the UID is actually embedded directly into the Corelight Suricata alert in this instrumentation. And, how much time does that save per investigation? A couple seconds, a couple minutes maybe, depending on how you're set up and instrumented. But if you think about at scale, if you're processing, hundreds, thousands of alerts, that time savings can be immense, and it's a really great workflow acceleration. And Alex, I think maybe you could walk us through some examples here of kind of what this looks like from a data investigation perspective.
Yeah, absolutely. So going to a simple but powerful case here, we've got a Suricata signature that is just policy driven for executable or DLL window download over HTTP. And that's the sort of signature that a lot of folks wish they could leave turned on because it might alert them to malicious things coming across their network, but have a difficult time actually doing in production because of the volume of perfectly legitimate executables that cross the internet over HTTP. And in this case, we've gone ahead and see if I can actually advance the slide here. Taken that UID, again, into the Suricata Corelight logs here and directly extended it into the file log so that we can see exactly which files were downloaded on this connection that triggered the event. And of course, because we have the crypto checksums pre-calculated on all the files that we extract on the wire, it's very easy to then do a pivot into VirusTotal or any other hash checking service that you might like and be able to quickly see whether or not you've got a piece of malware, as is the case in this screenshot, or you've got a legitimate Windows DLL coming down that everybody recognizes as clean. This is a process, obviously, that manually can be done very quickly, but also lends itself extremely well to automation. If you're doing any kind of SOAR or other sorts of computerized processing of events before they get to humans, this is something that can be scripted into those tools by even the most novice user of those systems. And so it really helps you attach this type of a workflow to any sort of a place where files may be transferred, and you can automatically have that disposition embedded in the analytics to either dispose of things that are not malicious, raise incident priority for ones that are, and to bring that data to the human analyst quickly so they can make an intelligent decision point. And the same concept extends well to like a SQL injection alert here, for example. Seems to have been a bit of a snafu with the slide because I didn't show the alert here, but Again, doing that same UID pivot off of a Suricata alert, we're able to come in to an HTTP log, very quickly see that, yes, indeed, this is a SQL inject statement coming in across that URI. But the status code that was returned from the web server was a 404 not found, which is a very common kind of a scenario because there are so many automated scanning tools hitting websites across the entire internet. You really want to make sure that you're letting the computers fight each other and discard all of these cases where someone is just spamming every website they can find and hoping to get a vulnerable script on the far end. Now, if you had a 500 series status code coming back off of this, that's a little bit different. You can't just quite discard it because it might be indicative of somebody trying to figure out how to inject your site. And so maybe at that point you want to correlate large numbers of those events into a broader ticket and look for threshold levels of activity to be concerned with there. And even if you're talking about a 200 OK, sometimes that's indicative of a SQL injection having actually successfully occurred. Other times you've got web servers that will wrap those 500 series type of script errors in a 200 OK so as to make it more difficult for a SQL injection tool to figure out if it's working properly or not. And so again, the Corelight or the Zeek log data is really going to give you additional insight that is going to help you prioritize things intelligently with, for example, the response body length field in the HTTP log. If it's something like the 200 bytes we saw in the 404 a moment ago coming out of a 200 OK on a select statement, yeah, that's probably not as big of a deal as something like this where you have over a megabyte worth of data coming back on a select statement that looks very clearly designed to do its injection job beyond just even the initial scanning level. This is the I've successfully gone in and gotten injection and now I'm pulling data back out kind of a structure there. So again, having this data quickly at your fingertips is really going to help accelerate the process of pivoting through the data and getting to the resolution you need out of the giant pile of events coming into any SOC on the planet these days.
Great, thank you, Alex. We've got about 3 minutes left and over a dozen questions, so let's play a rapid fire Q&A here and keep it short and sweet. Quick question here, can either or both of these tools be run on a Raspberry Pi 4? Alex?
Yes, they can. As noted with one of the other answers in the question section, performance can be an issue, but absolutely open source as well as commercial from Corelight. We've got a software sensor version of the product that runs on the Raspberry Pi as well these days. And I'll speak quickly to ESXi since I saw that as well as a deployment question. This does work fine on a 10 gig link as long as you've got the drivers on ESX to read the packets in. That doesn't make a difference. It's about speccing it intelligently so that you have enough resources to be able to keep up with that 10 gig pipe.
Hey, John, it's Matt. I'll just jump in because I noticed that there was also a question about Dockerizing Suricata and Zeek and everything. For the folks who have been asking about kind of Docker, it seems like we've had a lot of questions about different types of platforms and whatnot. I think the answers are still very similar, right? Once, assuming you can get things allocated correctly, CPU dedicated and things like that, these tools are happy to work and run together. It's just making sure you can support the types of data that you're going to be throwing at it and that it has enough resources to subsequently parse as well.
Which also speaks to the question about differentiating from security onion solutions. In addition to that UID pivot, making it a step simpler to get between the logs, we find again that the security onion products don't do well above maybe 3 or 4 gigs worth of throughput. And so for smaller offices, it's a reasonable enough design pattern, but if you're getting into larger data centers or other enterprise environments, we're going to be providing more of the performance that you need.
And I'll add one thought to that, Alex, to close us out and also answer a second question that was asked as it relates to it. So in addition to those two kind of differentiators Alex mentioned, I think there's a lot of stuff Corelight has developed on top of the open source frameworks that don't exist in the open source world. Great example of that would be we ship in our sensors a set of Zeek packages called the encrypted traffic collection that are proprietary to Corelight. It's a dozen plus individual insights into encrypted traffic without decryption. And that was another question that got asked in the Q&A about what about encrypted traffic. I think we covered it a little bit in this webinar. There's other webinars we've done with SANS that go much more in depth in terms of Zeek's capabilities. But I would say the short answer there is Zeek can log in great depth the encrypted protocols of note. So SSL traffic, Kerberos traffic, SSH traffic. So you're getting detailed metadata information about the nature of the handshake, the certificate details. There's a lot of powerful insight and action you can squeeze out of that. On top of that, there's a lot of very interesting scripting work and automation that's been done on top of that data set. JA3 got mentioned. That's the ability to fingerprint client-server TLS connections, so you can actually start blacklisting and whitelisting them in your environment. There's a lot you can do with encrypted traffic. And to quickly answer a third question that got asked, where else in SANS can I look for more information on Zeek and Suricata? I know on the Zeek side, we've done a bunch of webinars, many of which we've done with you, Matt, going in depth about Zeek, specific hunting use cases, incident response workflows. So if you Google or if you go on the SANS website, you should be able to quickly pull those up. We've done a number of Corelight webinars over the last couple of years on Zeek use. Suricata side, this is our first that we've done, but I'm sure there's many more resources there, Matt.
I want to speak to one of the other questions there about when will Phantom playbooks be available. So Corelight is in the process of putting together a number of playbooks based upon our integrated Suricata and Zeek data. We are targeting Phantom as the first platform to generate those for because of its place in the market as a dominant force there. I don't want to commit to an exact time frame at this point because it is one among many projects that we're working through to try to bring additional value here, but it is extremely high priority as far as we're concerned, and I'm certain there will be stuff out well before the end of the year. So stay tuned on the Corelight blog for more information on that.
Great. Well, thank you, Matt. Thank you, Alex, and thank you, Jessica, for helping us put this on today. If we didn't get to your Q&A, I believe they're logged by Zoom, so we can follow up with you afterwards. And a recorded copy of this presentation will be made available on the SANS website, I believe.
All right, that's all the time that we do have for today. Thank you to our speakers, John, Matt, and Alex, for that great presentation, and to Corelight for sponsoring this webcast, which helps brings this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.